Hi guys, welcome back to CalcFly videos. In this video, we're going to be talking about question 6 from 2018 AP Calculus for response problem. So basically this problem is mainly about the solving differential equations using the separation of variables. Alright, we're also given this differential equation, dy over dx is equal to 1/3 x times y minus 2 to the power of 2. We're also given the slope field representing this differential equation. So in part A, it says, a slope field for the given differential equation is shown below. So sketch the solution curve that passes through 0, 2. So as you can see that 0, 2 is right here. So basically, the solution curve that passes through the 0, 2 will be this horizontal line, y equals 2 line actually. Okay. Then it says, sketch the solution curve that passes through the point 1, 0. So the 1, 0 is right here. So basically the curve that passes through will be this one. Okay. And also we're going to follow this curve, so it's going to be equal to like this. Okay, that's the solution curve that passes through 1, 0. So we did part A. Okay, let's do part B. In part B, it says, let y equals f of x be a particular solution to the given differential equation. And then we are given this initial condition, f of 1 is equal to 0, which means x coordinate is 1, y coordinate is 0. So write an equation for the tangent line of f of x at x equals 1. So in order to write down the tangent line equation, we need to know the slope. We're actually given the slope, which is 1/3 x times y minus 2, all to the power of 2. Basically, we need to evaluate this slope at when x equals 1 and when y equals 0. So basically, what I mean, dy over dx 1, 0, it's going to give us the slope. So if I plug in these values, substitute right here, we get 1/3 times x, which is 1, times 0 minus 2 squared. And this is going to be equal to just 4/3. So this is the slope of the tangent line at this point. So now we know the x coordinate, we know the y coordinate, and we also know the slope. Alright, so it's easy to figure out the tangent line equation. So y minus 0 equals 4/3 times x minus 1. So we get y equals 4/3 x minus 4/3. Okay, so this is the tangent line equation. So now we're going to approximate this f of 0.7 using this tangent line equation, which means we're going to take the 0.7 and substitute right here. So you get 4/3 times 0.7 minus 4/3. So the answer is going to be equal to just negative 0.4. Alright, we've just approximated the value 0.7, so we got this answer negative 0.4. Alright, let's move on to part C. And part C says, find a particular solution to the y equals f of x to the given differential equation with initial condition f of 1 is equal to 0. Which means we need to solve this differential equation using the separation of variables, and we need to find a particular solution using this given fact. Alright, let me clean up the board really quick, and then we're going to move on to part D. Alright, the part D. So if I do the cross multiplication, what I'm going to get is dy over y minus 2 squared. That's going to be equal to 1/3 x dx. So since we, successfully managed to get the variables separated on both sides, now we're going to take the integral of both sides. So we get negative 1 over y minus 2 equals 1/6 times x squared plus c. Okay, so my ultimate goal is to solve this equation for y. So basically, y minus 2, that's going to be equal to negative 1 over 6x squared plus c. Okay, and if I add 2 to each side, I'm going to get y equals 2 minus 1 over 6x squared plus c. So this is going to be my general solution. So if I want to find my particular solution, I need to use this fact. F of 1 is equal to 0, which means I'm going to plug in 1 for x, and I'm going to plug in 0 for y, and solve the equation for c. So 0 equals 2 minus 1 over 6 plus c. From this equation, if I solve this equation for c, c is going to be equal to 1/3. Then my particular solution will be, if I take this, y equals 2 minus 1 over 6x squared plus 1/3. So this is my particular solution to the given differential equation. Alright guys, thanks so much for watching this video. This video was mainly about the differential equations using the slope fields and finding the particular solution. Thanks so much for watching. Don't forget to subscribe, like, share, and comment. Please subscribe for the many more math content. See you in the next video. Bye-bye.